How do I know when this is recording? It does say recording. Yeah, but when somebody else is, okay, so when somebody else is recording, that's when it says you are being recorded, right? So you know, okay. All right, so what was I saying? Yeah, I only saw it last Thursday. That's the only time. And because I was out on Friday. So we've done a couple examples with similar triangles. All this stuff deals with similar polygons. So I'm going to go over those two examples that we've done with similar triangles, finding missing sides. The triangles are similar by angle. Then we use that information to know that the triangles are similar, and we can set up ratios and proportions and use that to find missing sides. Okay, and then it reviews scale factor and all that other stuff. So we're going to do two note examples in our notes, which means like normally you have a notebook out, pen or pencil. Did we forget how school works? I don't like the way I look on this camera. It's like an HD camera. I gotta like hide my wrinkles and bags under my eyes and stuff like that. Don't see me. Don't look at me. Don't look at me. Oh, sorry. No one's on the screen.
Does anyone use it?
But I am still recording it just for you can watch it later. I'm gonna post this on Canvas. I'll post the link on Canvas, and if you like want to review how to do that problem, then you have a review. Okay, so the first type of problem we looked at. Maybe I shouldn't use red. Probably hard to see red in the book. Oh, no, you can see it.
You can end it any day you want.
All right, so we're gonna find x and y. I already explained that these two triangles are similar by angle. Why are these triangles similar by angle? Where are the angles? How do we know angles are congruent? I turn the camera that way and it shows more of that board because it's like it's like backwards. Okay, so what do we know? Why do we have angles congruent? Parallel lines. And parallel lines tell us stuff about angles. What type of angles do we have in this diagram? Like I'm walking better, see? Even though I'm going to the doctor to get checked out. Congruent, yeah, what kind of angles? Corresponding angles, good. Parallel lines, corresponding angles congruent. Parallel lines, corresponding angles congruent. There's our angle. We could also share that this little, or we could also say that this little triangle shares an angle with the big triangle. So there's our third angle. We don't need it, but there's our third angle, but we could also use those angles maybe to help us draw or redraw the two triangles that are similar. This little triangle, angle, and then this angle. In between those marks, we have a 5. In between those marks, we have a 6. In between those marks, we have an X. So those are the sides of the smaller triangle. The big triangle. We've got this angle. Uh-oh, see? Look, I'm off the screen. Oh, I lied. Never mind. It is going the right direction. We've got this angle, and we've got this angle. What's the length of this side? 14, yeah. 6 plus 8. That whole length is 14. What's the length of this side? 5 plus y, right? You add those to get this side. You add those to get this side. What's the base or bottom side? It's not really 20. Okay, so there's our missing sides. The scale factor is found by matching up the sides that we know the lengths of. Don't know that one. Don't know that one. Oh, we know this one. 6 and 14 form our ratio. If we want, we can put that in lower terms. If we reduce that fraction, we get 3/7. What do we call this? Good, that's the scale factor. The scale factor is 3/7. For every 3 units in this triangle, we have 7 units in this triangle. 3/7. You could use either one of those ratios to find the other missing sides. I always like to put it in lower terms. It's easier to multiply smaller numbers. So 3/7 or 6/14 equals x over 20. This over this equals this over this. Or 3/7 equals 5/5 plus y. This is like, and then you like keep moving this over so it's not so slanted. All right, then you have two proportions. How do you solve a proportion? Cross multiply. 7 times x is 7x. 20 times 3, 60. Sorry, you're the one that emailed that you're gonna be gone too, right? For a while, when does that start? Huh? Oh, it got canceled? Oh, okay. Because of COVID? COVID root stuff. All right, so 7x equals 60. X equals 9 4/7. Cross multiply here. Whenever you have an expression, make sure you use parentheses. So we got 5 times 7, which is 35, equals 3 times 5 plus y. 35 equals 15 plus 3y. 3y equals 20. Y equals 6 1/3. Right? So that's one of the types of triangles one of the diagrams we've been using to find missing sides of right triangles. All right, we've also just set up, we had 2 triangles. We've also just had 2 rectangles. Set those things up. Find missing sides. All right, question on this type of example? Oh, the other thing we have to review is scale factor. Shoot, right? What's that? What happened with the pages 17 through 19 on Friday when I wasn't here? How'd that go? No, the last one, yes, the last one.
You were supposed to set like
Yeah, the angles you could set equal to each other. But for the sides, you have to like add them together and set up a huge proportion. You get this ugly quad.
Yeah.
Stop recording. You get this ugly quadratic. Why did I do that? Why did that happen? You get this ugly, I was gonna say angle and it came out. Yeah. All right, and now I'm not posting this. I can't put that out for the world to hear.
You have to edit it out.
You have to edit my, I have to edit my video.
Put up worms.
Oh my God.
You
What's
said the
wrong?
no word.
Yeah, I said angle side side.
Sure.
That's what I was trying to say. Angle side side is not a way to prove triangles similar. All right. All right, yeah, don't worry about the last problem on the review. Okay, we good? Can I give you guys time to copy down the rest? I'm gonna erase. All right, we'll do one more example here. Why did I do that? Now I'm definitely not posting this video because you guys are gonna find it on YouTube and then be like, put it on Snapchat, it'll be on your story. No way, no. Then I'm gonna get fired for saying the A word.
To be honest with you.
Wait, other teachers swear?
Yeah.
Oh,
High school, no one cares.
never. in the previous problems that we've done, I've only given you one missing side. I've only asked you to find one variable. So in this problem now, I'm going to show you how to find all the missing sides and all three of the triangles. So now I put three different variables up there. Again, what's the way I said makes these problems easier to solve? Do what? What do we do in the first example? Separate them out, right? Redraw the three similar triangles. Right? So when I redraw the three similar triangles, I draw them according, in this example at least, the way the big triangle looks. So I want them all facing that same way, where the base, all the ones that go with Z and Y are on the left or on the bottom and the left, and all the hypotenuses are going to be in the same spot. What do you guys know what hypotenuse is? It's the longest side. It's the side opposite the right angle. Okay, so I'm going to draw my first triangle so it looks just like the original, or try to at least. Okay, just like that. And I'm going to redraw the other two. So we got a medium-sized triangle. Having a hard time drawing today. Got the medium-sized triangle and then the smallest triangle. Okay, so the big one is this one. This medium-sized one is this one. And then the littlest one is this one. Now, the other thing that helps out is mark the angles. We've got a right angle. We've got the smaller angle. And then the other acute angle. Now I'm going to mark the big diagram. I'm going to mark all three the same way because the angles, the corresponding angles are congruent. So right angle, right angle, right angle. Smallest angle, smallest angle, smallest angle. And then we're going to have our other acute angle, other acute angle, other acute angle. When you mark the angles, it helps us be able to write down the lengths of the sides. You guys have never seen a TikTok that had a swear on it before, so that's why I feel bad. Okay.
For the medium triangle, the double is on the top.
No, I'm drawing them all the same way. I'm gonna flip that triangle around. Okay. So in the big triangle, what's the hypotenuse? 10. What's this side? And the bottom? Z. All right, now this is the medium-sized triangle. Okay. So the right angle in the medium-sized triangle is there. What's the side opposite the right angle? Z. Yeah, the hypotenuse is Z. So I'm putting Z there. Now, in between the right angle and the double tick mark is a 6. In between the right angle and the double tick mark is a 6. This triangle doesn't have a single tick mark, but it's this angle. Our next side has to be the other side that's in that triangle. It's an X. Can you label the smaller one? Try to label the smaller one. What's going to go where? What's the hypotenuse? And then match up any of the angles that are the same and write in the missing side. You didn't even do it. Just wait for me to do it. You're supposed to be filling in the missing sides. Okay, thought you did? Okay. Opposite the right angle. Now what's the hypotenuse?
Why?
That's what I'm asking you. Why? in between the right angle and this one, and we don't have it this angle, but we do have a right angle in this type of angle. The right angle in this type of angle, the single tick mark is a 4. And then our third side would have to be whatever's left. We got a y of 4, so the third side has to be x. Okay? So that's how you label the triangles. Now, before, if we were just finding x, we would find the two equations that had, or the two triangles that had x, and we would set up a proportion. We can do the same thing here. These are the two triangles that have x as a variable. What does this x go with? 4. So x over 4 equals, now I could do z over y. Is that going to help me solve for anything? So let's do 6 over x. We can cross multiply and solve for x. X squared equals 24. X equals the square root of 24, which is some ugly, yes. Ugly equal side decimal. All right. Set up an equation for y. Use the two triangles that have y. So what's one of them? What's one of the ratios? 10 over y. Okay, we can do 10 over y, the hypotenuse. 10 over y equals 10 over y equals y over 4. Good. Equals y over 4. You cross multiply, solve for y. Y squared equals 40. Y equals the square root of 40. Okay, last one, z. Z, use the two triangles that have z. Ten over z equals what? Z over 6. So again, cross multiply, z squared equals 60. Z equals the square root of 60. Now you can just write this if you want, or you can write the decimals. All right, if you got the square root of 36 though, you should be writing 6. In a couple units, I'll be teaching you how to simplify these. All right. Questions? All right, so those are two different examples. You had a bunch more on Friday, some like the shadow problems. Anytime I give you a problem where it says like the ratio of this to this, or the ratio of this to this to this, or the ratio of this to this to this to this, you attach a variable. So if I said the ratio is 10 to 9 to 8 to 7, the ratio is 10 to 9 to 8 to 7, and the total is 100. Well, if the ratio is 10 to 9 to 8 to 7, that means I'm multiplying 10 by something, 9 by something, 8 by something, and 7 by something. So you attach the variables. And if I say the total is, what did I say the total was? 100. You would set it equal to 100, and then you would solve for x, plug them back in, and no matter what you get for x, you plug it back in here, that's going to be the ratio. If you got x is 2, you're going to have 20 to 18 to 16 to 14. And then they'd be in the ratio of 10 to 9 to 8 to 7, same thing. Okay, so there's a couple problems in the review that my previous class had questions on. So if you can now go back, one of them was complementary, one was given the lengths of the sides and the perimeter. Then there was like those shadow problems, things like that. Okay, so I posted the answers. So the ones that you did, check. The ones that we didn't finish, we're going to finish today. And then if you don't need to worry, if you don't need to worry about finishing the last problem. If you could set it up, great. Otherwise, you get some ugly quadratics. I'm not going to give you, I mean, the leading coefficients is like a 4 or something like that. So we can figure that out later. All right. So pages 17 to 19 in your similarity packet. The answers are posted on Canvas. So check that out. And I can stop my recording. it.